All right, so now today we're going to talk about task 3.5, throwing an interception. This is another develop understanding task. So with this task, it's going to introduce us to a couple of new ideas, or a new idea. Let's get started. The x-intercepts of the graph of a function f of x are often very important because they are the solution to the equation f of x equals 0. In past tasks, we learned how to find the x-intercepts of the function by factoring, which works great for some functions, but not for others. In this task, we are going to work on a process to find the x-intercepts of any quadratic function that has them. We'll start by thinking about what we already know about a few specific quadratic functions, and then use what we know to generalize to all quadratic functions with x-intercepts. So we're talking about how do we find x-intercepts? And how can we find them better and in other different ways? So what can you say about the graph of this function? Well, if we factored this function, we would get that f of x equals x minus 3 and x plus 1. So this tells us that our x-intercepts would be at positive 3 and negative 1. So if I draw some axes here, we would have an x-intercept here at positive 3 and an x-intercept here at negative 1. If we plug in 0, our y-intercept is going to be negative 3. So that's right there. And then between these two x-intercepts, our line of symmetry is right here at 1. And if we plug in 1, we get 1 squared, which is 1, minus 2, so that would be negative 1, minus 3, so that would be negative 4. That gives us this point. And we know that's the line of symmetry because that's between our x-intercepts. So because we know that's the line of symmetry, we know that that's the vertex right here. So we can kind of graph that. And using our parent function knowledge, we know there's a point there. We know there's a point there. So here's our graph of the function. So graph the function, done. What is the equation of the line of symmetry? The line of symmetry is right here at x equals 1. And what is the vertex of the function? It's 1, negative 4. So that just gets us kind of in the mood for what we're going to be doing. Now let's think specifically about the x-intercepts. What are the x-intercepts of this graph? Well, they're here and here. We can tell from the factored form. So the x-intercepts would be x equals 3 and x equals negative 1. We can write them as points 3, 0 and negative 1, 0. How far are the x-intercepts from the line of symmetry? Well, in this case, the line of symmetry is here. So they are 2 points away, right? If the line of symmetry is here, I could go from the line of symmetry 2 to the right and get a point, or 2 to the left and get a point. So they are 2 units away from the line of symmetry. If you knew the line of symmetry was the line x equals h, and you know how far the x-intercepts are from the line of symmetry, how would you find the actual x-intercepts? Well, I would just count. I would count away on the x-axis. I would count away from h, whatever h is, I would count away from h on the x-axis. However far, it says if I knew how far the intercepts are, then I would just count away. So like if I knew they were 5 away, I would just start at h and then I would count 5 away on the left and on the right. I'm going to add that on the left and on the right. Of the line of symmetry. How far above the vertex are the x-intercepts? So the vertex is here. The x-intercepts are 4 above. So they're 4 units above. 4 units above. And what is the value of f of x at the x-intercepts? The value of f of x is 0. That's what makes them x-intercepts, right? Is that the y value is 0. The f of x value is 0. There's some key things here, which the task is going to point out, but just keep in mind that they were 2 units away from the line of symmetry, and they were 4 units above the vertex. That's going to be important. Okay, so let's keep going. Just to make it a little easier to talk about some of the features that relate to the intercepts, let's name them with variables. From now on, when we talk about the distance from the line of symmetry to either of the x-intercepts, we're going to call it d. So here they have a drawing here. You can see the line of symmetry is this dotted line. And if you measure from the dotted line to the x-intercept, that's going to be called d. The diagram below shows this feature. We will always refer to the line of symmetry as the line x equals h. So from now on, the line of symmetry, we're going to call that h, x equals h. So the two x-intercepts will always be h minus d, comma 0, and h plus d. So you start at h and you either add d or you subtract d. And then the y value is always 0. Okay. So let's think about another function. Here's another function. Graph the function by putting the equation into vertex form. So to do that, we're going to complete the square, which we learned how to do before. So we can say f of x equals x squared minus 6x plus 9 minus 5, right? We want it, that's all about this number. We talked about how to get that number and then how to adjust there. So then this, we can factor into x minus 3 and x minus 3. This becomes x minus 3 squared, and that's minus 5. So we can graph this function now. We know the vertex is going to be at 3 and negative 5. 1, 2, 3, 4, 5. So we know this is the vertex. We know the stretch value or the dilation is 1. So we can just use our parent function pattern. We know this is happening. So 1, 3, and then 5. 1, 2, 3, 4, 5. We get a point there and a point there. Right? And here's our line of symmetry right here. Okay, so we graph the function. We put it into vertex form to find the vertex, which is here, and then we graph the points. Okay, what is the vertex of the function, it asks? Well, the vertex is 3, negative 5. And the equation of the line of symmetry was x equals 3. What do you estimate the x-intercepts of the function to be? Well, if we look, if it's going to cross here, kind of between 0 and 1, and it's going to cross here, which is between 1, 2, 3, 4, 5. It's going to cross between 5 and 6. So it says estimate. So I'm just going to do a rough estimate. I think it's going to be 0.5, 0. And between 5 and 6, I think it's 5.5, 0. And what do you estimate D to be? I think D, if we were just estimating, I think it's going to be 1, 2.5. I think D is 2.5. Again, this is just an estimate. It's not the actual precise amount, but it's close enough. We can go 1, 2.5, and then 1, 2.5 away from the line of symmetry. And then what is the value of f of x at the x-intercepts? It's 0, right? So if I plug in, the idea would be if I plug in 2.5, I'll get a value that's real close to 0, or not 2.5. If I plug in 0.5, get a value close to 0. If I plug in 5.5, get a value close to 0, right? Those are the f of x values here and here. They're 0. Okay, let's keep going. Okay, this says using the vertex form of the equation and your answer to part f above, write an equation and solve it to find the exact values of the x-intercepts. So, okay, So my vertex form equation was f of x equals x minus 3 squared. No, was that plus 3 or minus 3? Yeah, minus, it's right, that's minus 3. X minus 3 squared minus 5. Since we know that f needs to be 0, we can say, well, what? We can change this to a 0. And by doing that, we're saying, okay, well, since we know f has to be 0, what can we figure out for x to make this true? And now we can solve this. So we can add 5 to both sides. That'll give us 5 equals x minus 3 squared. Then we can use what we learned about square roots. We can take the square root of both sides. And that's going to be x minus 3. Remember, when we cancel a square root, we need to put a plus version and a minus version. We're going to do both versions at the same time. So we're going to put plus and minus. And then we can add 3 to both sides. So that'll give us 3 plus or minus the square root of 5 equals x. In other words, another way to think of this, we'll have 3 plus square root of 5, and we'll have 3 minus square root of 5. And those will equal x. So this is our line of symmetry, right? Because that's 3. And so we're either adding square root of 5 or we're taking away square root of 5. So the exact value of d is actually the square root of 5. So the exact value of d is the square root of 5. Use a calculator to find approximations of the x-intercepts. How do they compare with your estimates? So remember, we guessed 0.5 and 5.5 on the other page. Well, let's see what the square root of 5 is, and let's actually calculate this in the calculator and get some approximations. So if I put 3 plus the square root of 5, 3 plus the square root of 5 is approximately 5.24. And 3 minus the square root of 5 is approximately 0.76, approximately. How do they compare? Well, I thought it was going to be 5.5 and 0.5. These are pretty close. And these are pretty close. They're close. They're close. Right, but this is a better approximation, and this is the exact value. Remember, square roots, we don't have a precise value for some of these square roots, but we can just write it as a square root of 5, and that'll be an exact value. Okay, what about a function with a vertical stretch? Can we find exact values for the x-intercepts the same way? So let's try it. Graph the function by putting it into vertex form. Okay, let's put it in vertex form. We're going to start by factoring out 2x squared minus 4x plus 5. We're going to need an extra 4 in there. So since we're adding 4, we're actually adding 8. We're going to subtract 8. That's going to give us 2x squared minus 4x plus 4 minus 3. We can factor this as x minus 2 times x minus 2. Like that, there's our vertex form, and we can graph this. So let's graph it. Okay, our vertex is going to be at 2, -3. So 1, 2, and then -3. Here's our vertex. The line of symmetry will be at x equals 2 because it's right down the middle. Since this is a dilation, we can finish graphing it. Since this is a dilation of 2, we can follow the parent function. So it'll be 2 and then 6. 1, 2, 3, 4, 5, 6. 5, 6. What do you estimate the x-intercepts are? Okay, well, there's an x-intercept like right there, kind of in between 0 and 1. And there's another one in between 3 and 4. So let's go ahead and just estimate 0.5 and 3.5. Right? It's right around 0.5 and 3.5. It would help if you guys could see it, huh? So what do we estimate D to be? Well, if the middle is here, that looks like about 1.5. Estimated to be about 1.5, right? So starting in the middle, 1.5 to the left and 1.5 to the right. And obviously the value of f(x) is 0 because f of x represents the y value here. And both of those are 0. Okay, so now let's go to the next problem. It says using the vertex form of the equation, so that was f of x equals 2 times x minus 2 squared minus 3. And because we know f has to be 0, we can put 0 here. And we can solve it for x. So we can add 3 to both sides. Like this. Now we want to divide by 2 on both sides. And that'll cancel with this 2. Equals x minus 2 squared. Now we're going to take the square root of both sides. Remember, when we take the square root, there's going to be a positive version and a negative version. So we can say there's going to be a plus square root of 3 over 2 equals x minus 2. And there's going to be minus square root 3 over 2 equals x minus 2. And then we can add 2 to both sides. So we get 2 plus the square root of 3 over 2 equals x. And if we add 2 over here, 2 minus the square root of 3 over 2 equals x. So 2 is our line of symmetry, right? And so these are our two x-intercepts. We're adding a little bit and we're subtracting a little bit, right? We're adding and subtracting. So the exact value of D, remember, D is how far the line of symmetry is away from each x-intercept. It's going to be the square root of 3 over 2. So compare your solution to your estimate of the roots. How did you do? Well, let's plug this in to the calculator and see what we get. So if we do square root of 3 over 2, that is approximately 1.22. And if we do 2 plus the square root of 3 over 2, that's approximately 3.22. And if we do 2 minus the square root of 3 over 2, that's approximately 0.78. And remember that what we estimated was 0.5 and 3.5. So again, these are pretty close. They're pretty close. Again, these are the exact answers here. Okay, it says finally, let's try to generalize this process by using f of x equals ax squared plus bx plus c to represent any quadratic function that has x-intercepts. Here's a possible graph. Start the process the usual way by putting the equation into vertex form. It's a little tricky, but just do the same thing with a, b, and c as what you did with the last problem with the numbers. Now this is where you want to maybe go a little slower, pause the video, and make sure you're understanding all the steps, okay? So if we have f of x equals ax squared plus bx plus c, the first thing that we did before was we factored out a from these two. So that's what we're going to do. We're going to factor that out. We're going to factor a out. That's going to give us x squared, and that's going to give us b over a x like this, plus c. Then what we did was we took half of this and we squared it, and that told us what to add in here. So that's what we're going to do. We're going to take half of that and square it. Half of b over a is b over 2a, okay? And then when we square that, that's going to be b over 2a squared. So plus b over a x plus b over 2a squared, okay? Now, since we added that, we also have to subtract it outside. And when we subtract it, we need to make sure that we multiply this times this. So when we do that, we're going to subtract b squared over 4a. And the reason why we subtract b squared over 4a is because b over 2a squared is, using exponent rules, that's the same as b squared over 4a squared. And then if you multiply, so that's what this is, right? So b over 2a squared, which is what we have here, is this. So if we added this right here, we also need to subtract it, but on our way out, we need to multiply by this a. And so when you multiply by the a, it cancels out one of these a's that's dividing, and that's why you don't have this little squared on the a. And then the c is going to stay the same. Okay, now what we do is we factor this. So when we write the vertex form, it's always a, this is squared, and then in the middle, what we put here, this is always ending up to be half of whatever this is, which is b over 2a. So we end up with x plus b over 2a. Half of this goes here. So like, for example, in the same way over here, right, this was -4. We took half, and that was -2. Right? And that's always the case, right? If that was a -6, this would be a -3, and so on. So if you have this here, half of this is b over 2a. And then we can put these together over here. We usually put them together, and usually when we put them together, we have like a common denominator. So we can put, let's multiply this by 4a and this by 4. So this would be c times 4a over 4a like that, and then we can put them together. So that would be minus b squared over 4a plus 4ac over 4a. We can put these together. We have to be careful because if you accidentally put them both together right away, the negative will distribute, and we don't want that because this needs to be positive. So the way we can get around that is we can say x plus b over 2a squared. I'm just copying that. And what we're going to do is we're going to swap these so that the positive's in the front, just to make it a little bit easier. 4ac minus b squared over 4a, something like that. Okay, so it's a big mess, it's a big mess. But what is the vertex? Well, we always know that the x value of the vertex is whatever's in here. So the x value of the vertex is here, and it's usually the negative, it's the opposite of what's in there. So it's negative b over 2a. And the y value of the vertex is always what's out here. So that's going to be 4ac minus b squared over 4a. So that's your vertex. It's just, I just took all this and I just put it down in there. This is, by the way, how formulas get made, is that you've done a problem so many times that you swap out all the numbers for letters, and then you just, you do the same thing with the numbers that you do with the letters, except obviously when you're working with letters, if you're dividing, it doesn't equal a new letter, it just equals a fraction, you know, where if you divide numbers, usually it equals a new number, but with letters, it just equals a fraction. Okay, so that's the vertex. Interesting, huh? A little complicated, but again, you can go back and rewatch that. And if you have questions, please ask your teacher. This is really some valuable information for the quadratic formula, which we're going to learn a little bit later. Okay, let's keep going. Okay, what is the line of symmetry of the parabola? Well, remember the line of symmetry is always the same as the x value of the vertex. So this is going to be x equals negative b over 2a. So that will be the line of symmetry. And it says write and solve the equation for the x-intercepts as you did previously. And so here, actually, this is where we're going to show the quadratic formula. The equation that we just had was f of x equals, it was a times x minus, or x plus b over 2a squared plus 4ac minus b squared over 4a. Okay, that was the equation that we just wrote. And if we're going to solve it, we need to treat this as a 0. Okay, so we're going to treat it as a 0. We're going to write 0 equals a times x plus b over 2a squared plus 4ac minus b squared over 4a. Now what we're going to do is we're going to just solve it. So we're going to subtract this over to the other side. So that's going to be negative 4ac minus b squared over 4a, like this. And that's going to equal a times x plus b over 2a squared. Then what we're going to do is we're going to divide by a. Before we divide by a, we're going to distribute this. And because I want to keep the positive number in the front, I'm just going to swap them. So when the negative multiplies the b squared, it's going to turn into positive b squared, and I'm going to just swap this with the positives in the front. So that's going to be b squared minus 4ac over 4a, and we divided by a, so we can just put, right, we divided both sides by a, so we can just put a squared here. And that's going to equal x plus b over 2a squared. Now we're going to take the square root of both sides. And remember, when you take the square root, there's always a plus version and a minus version. So I'm not going to rewrite it double times. I'm just going to put plus and minus to count for both versions. That's going to be b squared minus 4ac over 4a squared, like that. And that will equal x plus b over 2a. Now, something interesting. Sorry, there was an announcement over the loudspeaker here, so I had to pause the recording. But anyway, back to what I was saying. Square roots, when you have a fraction in the square roots, you can split up the square root so that you can have the square root of the top and the square root of the bottom. And the reason I care about that is because the bottom has a very nice square root, because the square root of 4 is 2, and the a squared, the square root of that is just a. So we can actually write this as plus or minus the square root of b squared minus 4ac, and then the square root of 4a squared, which is just 2a, like that. And then we can just subtract b over 2a from both sides. And that's going to give me negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Right? And the square root's only in the numerator, not in the denominator. And that is x. This is what's called a quadratic formula. So as you can see, all we did was we replaced where the numbers usually would go, we replaced it with letters. And as long as we were very careful about keeping track of all the letters, we were still able to solve as we normally do. But obviously, when you're working with letters instead of numbers, the letters don't combine together like the same way that numbers do, right? Like if you add numbers together, you just combine them and you get a new number. If you add letters together, they don't equal a new letter. They just stay. So we just basically did all the same stuff, and we just had to be careful that we were keeping track of everything. This is really valuable. You might want to pause or go back and watch this again and make sure you understand this and ask your teacher about it if you have questions. So it says, how could you use the solutions you just found to tell what the x-intercepts are for this function? So, okay, well, normally this would be A, right? And then this would be B, and then this would be C. That's what A represents. A represents the one that's in front, B represents the -3, and C represents the -1. So since I've already done all the solving, all I have to do is put these numbers right into this already solved version of the equation, and it will give me the answer. So if I just substitute A, B, and C into my solved version of the equation, then it is already solved. Right? Because if I plug it in here, I don't have to do any extra solving. I solved it once already. Now I just have to plug it in, and it already says x equals blah, 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 blah. So it's already solved. Okay, let's keep going. You may have found the algebra for writing the general quadratic function f of x equals ax squared plus bx plus c in vertex form a bit difficult. So it's talking about what I mentioned over here. It says you might have found this difficult. And like I said, if you did find it difficult, pause, rewatch, ask your teacher about it. Here's another way we can work with the general quadratic function leading to the same results you should have arrived at in 5D. You know, I think we're going to pause here because this task is fairly long. And the next section is going to be just as complicated as what we just did. And I don't want to overload you. So we're going to pause here. I'm going to upload this as its own separate video. And then I will upload the second half of 3.5 as its own separate video as well. Because it's just another way of getting this. Right here, it's another way of getting this. And if you're struggling with the algebra, then it's better to take your time and understand each part individually, okay? So I'm going to pause here and upload the video.